Well, hello there, future scientists. Rajan Sir here, ready to dive into an electrifying topic. Today we're talking about two amazing groups of materials, metals and non-metals. They are all around us in everything we use and see. Think about it. From the spoon you use for your breakfast cereal to the air you breathe. Understanding them is super important. It's like knowing the difference between a cat and a dog. They both have their unique characteristics, don't they? We are going to explore what makes a metal, and what makes a non-metal, well, a non-metal. It's going to be a fantastic journey of discovery, so buckle up.
Rajan Sir, this is so cool. But how can I tell if something in my house is a metal or a non-metal? It all looks so different. Is there a secret code or a special trick to it?
That's a fantastic question, Kashvi. It shows you're thinking like a true scientist. There isn't a secret code, but there are definitely clues, or what we scientists call properties. We can observe these properties to help us classify materials. It's like being a detective looking for evidence to solve a mystery. So, you want to be a material detective at home, Kashvi? That's a brilliant idea. You don't need a fancy laboratory to start exploring. Your home is full of examples. We can look at things like kitchen foil, some old nails, maybe even a piece of coal if you can find one, safely of course. These everyday items hold the secrets to understanding metals and non-metals. We just need to know what to look for. Are they shiny? Can we bend them? Do they make a sound when tapped? These simple questions are the start of our scientific investigation, so let's set up a mini investigation right now. Kashvi, and all you science enthusiasts at home, grab a few things. Find a piece of aluminum foil, the stuff used in the kitchen. See if you can find an iron nail, perhaps from a toolbox. Ask an adult for help. And if you have a piece of charcoal or coal, that would be great too. We're going to put these items to the test. We'll observe them closely, maybe tap them, try to bend them gently, and see what happens. This hands-on exploration is the best way to learn. Alright, Science Squad, let's get to our home activity. Take that aluminum foil. What do you notice first? It's shiny, right? That shininess is called luster. Most metals are lustrous. They reflect light really well, making them look bright and polished. Now look at the piece of coal. Is it shiny like the foil? Probably not. Non-metals are usually dull. They don't have that metallic gleam. The iron nail might be a bit rusty, but if you scratch it, you might see some shine underneath. This difference in luster is a big clue in our detective work. Next up, let's think about malleability. That's a big word. It just means you can hammer or press something into thin sheets without it breaking. Try gently pressing the aluminum foil. It flattens easily, doesn't it? Metals are generally malleable. Think about gold. It's so malleable it can be hammered into incredibly thin gold leaf. Now what about that piece of coal? If you tried to hammer it, it would just shatter into tiny pieces. Non-metals are usually brittle, meaning they break easily. This property is super useful for making things like car bodies or food cans. Now, let's consider ductility. This means you can draw the material into wires. Copper, a metal, is very ductile. That's why we use it for electrical wires. You can see these thin copper wires inside the plastic coating of many cables. Can you imagine trying to make a wire out of coal? It just wouldn't work. Metals like gold are so ductile that a single gram can be drawn into a wire over 2 kilometers long. That's amazing. This property is essential for making all sorts of wires, from those in our electronics to the strings on a guitar. Finally, let's talk about sonority and conductivity. Sonority means making a ringing sound when struck. Think about the school bell. It's made of metal and it rings loudly. If you tap the iron nail gently, it might make a bit of a ringing sound. Now, tap the coal. It makes a dull thud, right? Non-metals are generally not sonorous. Conductivity refers to how well a material allows heat or electricity to pass through it. Metals are excellent conductors. That's why cooking pots are made of metal, to conduct heat for food. Non-metals are usually poor conductors, which is why pot handles are often made of plastic or wood. Fun fact: graphene, a form of carbon, is an exception and is incredibly strong and a great conductor. Now that we've explored physical properties, let's dive into the exciting world of chemical properties. This is all about how metals and non-metals react with other substances. First up, oxygen. When metals react with oxygen, they usually form metal oxides. Think about magnesium. If you burn a magnesium ribbon, with adult supervision of course, it burns with a dazzling white light and forms a white powder called magnesium oxide. This magnesium oxide, when dissolved in water, turns red litmus paper blue, meaning it's basic in nature. This is a common trait for many metal oxides. What about non-metals and oxygen? Well, they react too, forming non-metal oxides. Let's take sulfur, a yellow non-metal. If you burn sulfur powder, it produces a gas called sulfur dioxide. It has a very distinct choking smell. Be careful. When this sulfur dioxide dissolves in water, it forms sulfurous acid. This acid will turn blue litmus paper red, indicating it's acidic. So you see a pattern here. Metal oxides are often basic, and non-metal oxides are often acidic. This difference in the nature of their oxides is a key chemical distinction between them. Let's consider water. Some metals react vigorously with water. Sodium is a great example. It's a very reactive metal. If you drop a tiny piece of sodium into water, again, a demonstration best left to experts, it zips around on the surface, fizzes, and can even catch fire, producing sodium hydroxide and hydrogen gas. Other metals, like iron, react much more slowly with water, forming rust over time. Most nonmetals, however, do not react with water in the same way. This reactivity with water is another important chemical property distinguishing many metals from nonmetals. And what about acids? Metals often react with dilute acids to produce hydrogen gas and a metal salt. Remember our friend zinc? If you put a piece of zinc metal into hydrochloric acid, you'll see bubbles forming. Those bubbles are hydrogen gas. We can even test for it. Hydrogen gas makes a pop sound when a burning splint is brought near it. Non-metals generally do not react with dilute acids to produce hydrogen gas. This reaction with acids is a classic test to identify many common metals. These chemical behaviors help us understand not just what things are, but what they can do. Now, let's think about a super cool type of chemical reaction called a displacement reaction. Imagine a game of musical chairs, but with elements. In these reactions, a more reactive metal can kick out or displace a less reactive metal from its compound solution. For instance, iron is more reactive than copper. So if you place an iron nail into a solution of blue copper sulfate, something amazing happens over time. The iron will slowly displace the copper. You'll see the blue color of the copper sulfate solution fade, and a reddish-brown coating of copper will form on the iron nail. The iron has taken copper's place in the solution. This displacement concept is really important. It shows us a kind of pecking order among metals, known as the reactivity series. This series helps us predict which reactions will happen. For example, a very reactive metal like potassium can displace most other metals from their compounds, while a less reactive metal like gold won't displace many at all. This is why gold is found as a pure element in nature. It doesn't like to react much. Understanding displacement reactions helps in processes like extracting metals from their ores, and in things like electroplating. Science is like understanding the rules of a giant cosmic game.
Wow, Rajan Sir. So, metals are usually shiny, bendy, make ringing sounds, and let heat and electricity pass through. They also react with oxygen to make basic stuff and with acids to make hydrogen. And nonmetals are mostly the opposite, dull, brittle, and they make acidic stuff with oxygen. And that displacement reaction is like the stronger kid getting the better seat.
You've got it, Kashvi. That's a fantastic summary. You're really thinking like a scientist
for
now,
watching. I
connecting
hope
all
you
these
enjoyed
observations
today's
and
video
ideas
and learned the
together.
topic well.
It's all about
For more
noticing
such
patterns
videos,
and
do
understanding
like, share,
properties.
and subscribe.
The uses
Also,
of
write your
metals and
suggestion in
non-metals
the
are
comment
everywhere
box.
in our daily lives. Metals like iron and steel are used for building strong structures, bridges, and cars. Copper is vital for electrical wiring. Aluminum is used for airplanes and drink cans because it's light and strong. Gold and silver are prized for jewelry. Non-metals are just as crucial. We breathe oxygen, a non-metal. Nitrogen, another non-metal, is essential for plant growth and is in fertilizers. Carbon, in its many forms, gives us fuels like coal and life itself. Plastics, made from non-metallic elements, are used for countless items. It's clear we need both metals and non-metals for the world we live in. So next time, we might explore what happens when we mix metals together to make something even stronger, or with special properties. We call those alloys. What do you think about that?